Hey Daisy, so to answer your question, it's because a Hess cycle comes in two parts. There's the equation the question asks you to find out about, so some kind of reactant will change into some kind of products and they'll ask you to find the delta H for that some kind of reaction. Let's call that pathway 1. And then you'll have to use the data given to you in the table, so they'll always give you some data to find some kind of alternative pathway. Let's call that pathway 2. And then Hess's law is pathway 1 equals pathway 2. So let's look at an example. Let's say the question said, find the enthalpy of formation of methane. So it's asking you to find the enthalpy of formation. Now, whatever the question's asking you to find, that's what we put across the top. So if we're finding the formation of methane, we're going to make 1 mole of chemical from its elements. And if it was standard, they'd be in their standard state. So it's giving us it's asked us about the formation. That's what goes across the top. The only way you'll know what your alternative pathway is by looking at the data given to you in the table. Now, this table tells us the enthalpies of combustion, so our alternative pathway must be via combustion, so we'll have our combustion products. So pathway 1 is finding about the enthalpy of formation, what the question asks. Pathway 2 is using the enthalpy of combustion data. That's not a problem to do that. So let's go through this and feed that data in. So to combust H2 is minus 286, and there's 2 moles of it. Add the carbon, minus 394. Using really quick maths and definitely not cheating, that comes to minus 966. Bang it in a box. Methane is just minus 882. Bang it in a box. And then we need to, Hess's law, we need to start and end in the same place. So we need to go from here to here. So my enthalpy of formation, root 1, will equal, I'm going with the arrow, so I keep the sign. I'm then going against the arrow, so I flip the sign. That becomes a positive, and that'll come to minus 104. Totally fine for the question to ask you about formation and the data to be on combustion, because the question is the equation going across the top, pathway 1, and the data in the table is the alternative pathway, pathway 2. What it couldn't do is ask you about formation and then give you the enthalpy of formation data. You would not be able to make a Hess cycle from that. So let's say you try one now. Blue Peter style here's one I made earlier. So if you want to stop this video, have a little crack at that, and then I'll go through the answer when you restart it. Welcome back. So it asks us to find the combustion of ethane. So that's going to be C2H4 plus 3O2 goes to 2CO2 and 2H2O. And we know that combustion goes across the top because that's what it asks for in the question. To find our alternative pathway, we look at the data given in the table, which is formation. So I need to form up from my elements. The formation of ethane, it tells us, is minus 84. It doesn't tell us the formation of O2, and that's okay because O2 is an element. And the enthalpy of formation of any element is 0. Look, if I was to do an equation for the formation of O2, I'm making 1 mole of O2 from its constituent elements. Look, I haven't done anything, so the formation must be 0. So it's essentially minus 84 add 0. That's our total there. And then for our right-hand side, and that will come to minus 1358. Our alternative pathway goes like this, starting and ending in the same place. Here's pathway 1, here's pathway 2. So pathway 1, our enthalpy of combustion is equal to, I'm now going against the arrow, so plus 84 with the arrow, so I keep the sign, minus 1358. Whap it in a calculator, minus 1274. So it's totally fine for the question to ask you for combustion and the data to be on formation. Again, one goes across the top, the other is the alternative pathway.